application. Now we take a question from the Hogg, McCain and Craig's book, that is question number 7.7.6a part. That is, suppose x1, x2 up to xn be the random sample from the uniform distribution, that is 1 over 2 theta 2, and its range is now theta 1 minus theta 2 less than x less than theta 1 plus theta 2, and the theta 1 is between minus infinity to plus infinity and theta 2 is greater than 0. Show that y1, which is the minimum statistic, and yn, that is the maximum statistic, are jointly sufficient statistic for theta 1 and theta 2 and are complete also. So in this case we have to prove two things: one, that y1 and yn are the jointly sufficient statistic, and secondly we have also show that it is a complete family as well. So how we proceed that? So again we need the joint distribution of y1 and yn, and we know that the joint distribution of y1 and yn, that is g of y1 yn, and that is equal to n into n minus 1 into f of y1 f of yn into f of yn capital minus f of y1 raised to power n minus 2. Now first we need to find the CDF of the y1. So that is f of y1, and that is equal to, from theta 1 minus theta 2 to y1, and that is 1 over 2 theta 2 d of y1, and that is very simple straightforward integration. And after evaluating that integral we will find that 1 over 2 theta 2, that is a constant, and that is y1 minus theta 1 plus theta 2. Now putting the values in the joint distribution, that is g of y1 into yn, and that is equal to n into n minus 1, and this is the distribution of y1 and yn, small y1 and small yn, that is the same, so we can write it as 1 over 2 theta 2 whole square into, that is yn minus theta 1 plus theta 2 minus y1 plus theta 1 minus theta 2 divided by, that is 2 theta 2 and whole raised to power n minus 2. After simplifying we get the joint density, that is g of y1 and yn, that is actually n into n minus 1 over 2 theta 2 raised to power n into yn minus y1 raised to power n minus 2. Next we need to find that the conditional distribution of sample given y1 and yn. So the conditional distribution f of x given y1 yn, that is actually phi I varies from 1 to n. For all samples we are going to find the distribution of sample, that is f of x theta 1 theta 2 over g of y1 yn, and that is actually equal to 1 over 2 theta 2 raised to power n into n minus 1 over 2 theta 2 raised to power n into yn minus y1 raised to power n minus 2. And after simplifying this will cancel out, and we will find the net result, that is the conditional distribution f of x given y1 yn, and that is equal to 1 over n into n minus 1 into yn minus y1 raised to power n minus 2. So once again we can see that the conditional distribution is free from the theta 1 and theta 2, since the conditional distribution of x given y1 yn is free from theta 1 and theta 2, so we can say that it is jointly sufficient statistic for theta 1 and theta 2. Next we have to look for the completeness, and for completeness we have a condition. We need to find actually expected value of g of y1 yn is equal to 0. So we can proceed as that is integral. So we need double integral in this case because we are handling the joint distribution. So that is theta 1 minus theta 2 to theta 1 plus theta 2, and the second integral, that is theta 1 minus theta 2 to y2, that is g of y1 yn, and that is with the joint distribution, that is n into n minus 1 over 2 theta 2 raised to power n into yn minus y1 raised to power n minus 2, and we need to integrate it dy1 and dyn. Sorry, that is dyn actually, not y2, and that is equal to 0. So multiplying both sides by 2 theta raised to power n, so it will vanish out. So the net integral will be, that is n into n minus 1 into integral theta 1 minus theta 2 to theta 1 plus theta 2 into integral theta 1 minus theta 2 to yn, that is g of y1 yn into yn minus y1 raised to power n minus 2 into d of y1 to d of yn, and that is equal to 0. So now differentiating with respect to theta 1 and theta 2, and differentiating both sides with respect to theta 1 and theta 2, we get the net result in term of g of theta 1 minus theta 2 and theta 1 plus theta 2, that is equal to 0 for all theta 1 and theta 2, and hence g of y1 yn, that is equal to 0. So by the definition of the complete statistic, y1 and yn are jointly complete sufficient statistic.